In this lesson, we are going to talk about assessing risk. Now, risk assessment is a process to identify potential hazards, and there's hazards everywhere in everyday life. There's risk in travel, there's risk with your health, there's risk with businesses. So I'm going to walk you through some examples on how you can calculate risk so that you can make better decisions about maybe how you travel or how you handle your health or how you run your business. Now, these methods that we're going to use involve relative frequency probabilities and expected values. So in the first example, it says, in a recent year, there were 633 deaths in general aviation over 8.8 billion miles flown. Find the fatality rate in units of deaths per 1 billion miles flown. So they're giving us information about the fatalities that they've observed in the past, which is 633 deaths per 8.8 billion miles flown. Now we need to figure out what the deaths are out of 1 billion miles flown. So I'm going to put X up here and create a proportion. I want to find the number of deaths out of 1 billion miles, and we are using the information that they gave us in the problem to create that proportion. So we're going to use cross multiplication to solve for X. When we cross multiply, we're going to get X is approximately 71.9 deaths. I'm going to round that up to the nearest whole number. And I'm going to say there's approximately 72 deaths for each 1 billion miles flown. Now we're going to use that same procedure for the second example. A 6-mile trip of Sprinkle Road had 49 traffic fatalities last year. There were 2.8 million miles driven along this stretch. Determine the traffic fatality rate per 100,000 miles driven. So the information that they're giving us is there were 49 deaths out of 2.8 million miles driven. We're going to set up a proportion to figure out the number of deaths out of 100,000 miles driven. We're going to cross multiply to solve for X, and we're going to get that X is about 1.75. I'm going to round that up to 2. Now just pay attention to the directions in your homework, how they want this rounded, but I'm going to round it to the nearest death. And I'm going to say approximately 2 deaths for every 100,000 miles. So that's a low risk. So you can identify whether it's a high risk or low risk. In this next example, it says the table shows the leading causes of death for one country in a single recent year. Assume a population of 77.5 million. In a typical city of 500,000, how many people would you expect to die by cancer in a year? So if we look at the table, the information for cancer is right here. It says, assume that the population is 77.5 million. So according to this table, 146,400 deaths occur out of that 77.5 million people. Now we want to figure out what that would be out of 500. We want to find the number of deaths due to cancer out of 500,000 people. So we're going to use cross multiplication to solve for X. When we solve for x, we get about 944.5 people, and we're going to round that up to the nearest person or the nearest death. So we can say approximately 945 people die from cancer out of 500,000 people. Okay, last example is based on business, assessing risk in business. So the question says the overall U.S. death rate for 60-year-olds is approximately 12 deaths for every 1,000 people. Suppose that a life insurance company insures 40,000 60-year-old people. The cost of the premium is $710 per year, and the death benefit if someone passes is $60,000. So what is the expected profit or loss for the insurance company? So we're going to use expected value for this. It's 100% chance, and I'm writing it as a decimal, that they're going to make $710 per year if someone purchased that policy. So this is the event that someone purchases the policy. And we multiply the value times the probability, and the value to the company would be a positive because they're taking in that money. However, then it states that the death rate is 12 deaths per 1,000 people. And if someone dies, they have to pay out $60,000. So for the next event where they have to pay out, they would have a loss of $60,000, and the probability of that happening is 12 out of 1,000. When we calculate this gives me, of course, a product of 710, and when I calculate negative 60,000 times 12 out of 1,000, that's going to give me a negative 720. So what's going to happen is there's going to be a $10 loss on average when they sell a $710 policy. Now, they said that they actually sell about 4,000 of these policies. So if we want to see the expected profit or loss, in this case it would be a loss, I would have to take 4,000 for each and times it by the loss of $10 for each policy, because that's 4,000 policies for each of those 60-year-old people. The insurance company is losing $10 for each of those on average. So we can say at that price of $710 for each policy per year, the company is going to lose $40,000. So in business, if you come up with this, you might want to reconsider how much you're charging for your policy.